Welcome, guys. So today we have this question that we have to look at. It says the total surface area of a rectangular parallelepiped of square base y on a side and height x is given by s is equals to 2y squared plus 4xy there. And we've been told to say if s is a constant, we have to find dy dx. So what they mean here is we have to differentiate this expression of s that we have there with respect to x. So now we're going to write this equation that we have there. We have s is equal to 2y to the power 2 plus 4xy like this. So now, since we've been told to say we find dy dx, this means that we're going to differentiate throughout this function, or rather we differentiate this whole function here with respect to x. So just write differentiating with respect to x there. So we differentiate throughout with respect to x. We introduce this expression this side, ds is equal to differentiate this function here with respect to x. We also differentiate that function then, or that term rather, with respect to x for x, y like this. So now, the method of differentiation that we're going to use here is called implicit differentiation. So under implicit differentiation, you notice to say when you are differentiating a variable with respect to a different variable there, you introduce dy dx at the end there because there are two different variables that we have there. So now bear in mind to say we've been told in the question to say s is a constant. So if s is a constant, we need to say the derivative of a constant this side gives us 0 there, which will be equal to, so now we're differentiating 2y squared with respect to x. So you notice to say this x and this y are two different variables. So how do we do this? The method we're going to use differentiating this here is called implicit differentiation. So under implicit differentiation, if you're differentiating two different variables there, we're going to differentiate this the normal way. So the derivative of 2y squared here is going to give us 4y like this. Then since this y that we're differentiating there is different from the variable that we're supposed to differentiate it with respect to, we introduce dy dx like this. Okay, so plus, if you look at this term that we have here, this is 4xy. If you look at this here, we're not going to treat this y as a constant, rather we treat it as a variable. So meaning that this here, we've got two functions that are being multiplied there. So if we have two functions there, or rather if we're differentiating two functions, we use the product rule. So the product rule, we keep the first function, we differentiate the second function there. So what I mean there is, we keep the first function, which is 4x, we differentiate with respect to x, the second function, which is y here, plus we keep the second function, y, we differentiate the first function there with respect to x, which is 4x like this. So now, here, this side, we keep the 0 the way it is, equal to 4y dy dx plus 4x multiplied by, so remember what we said initially there, we're differentiating y with respect to a different variable which is x here. So we're going to differentiate this normally. So when you differentiate this, we're going to get 1 there, 1. Then since these are two different variables, we're going to introduce dy dx like this. So now after we do that there, we go to this next function that we have there. So we're going to differentiate 4x with respect to x. So this x here and that x there is the same variable, so there's no need of introducing dy dx because we're differentiating x with respect to x, which is just the same variable there. So if we differentiate 4x there, we're just going to get 4. So it will be 4 multiplied by y, we have 4y like this. So now the question demands us to find dy dx. So at this stage here, we're just going to factor out dy dx on these two terms, then we take this the other side. So what we mean here is we're going to have 4y dy dx plus 4x dy dx equal to, when this 4y crosses the equal sign, isolating the 4y, we make it across the equal sign there, we're going to have negative 4y like this. So now, this side, the only thing that remains here is we need to factor out dy dx here on these two terms that we have there. So when we do that, you notice that we're going to have open brackets 4y plus 4x close brackets there, we have dy dx equal to negative 4y like this. So now, since we want to find dy dx here, so it means that we're going to divide both sides by 4y plus 4x. Even this side we divide by 4y plus 4x there. So this side, this and this will cancel. We're going to remain with dy dx equal to negative 4y divided by, so down there we've got 4 which is common there, we can just factor out the 4. So 4 open brackets y plus x there, so this 4 and that 4 there can cancel, so this is dy dx. So then our dy dx there is equal to negative y divided by y plus x there. Okay, so let's just run through the question there. So the question there, we were told to say we need to find dy dx there. So what we do here is we write the expression that will be given there in the question, so we differentiate throughout with respect to x. When we do that, we just show this here, showing that we're differentiating every term that is in this expression there with respect to x there. So when you differentiate s, remember I said s is a constant, so you differentiate that, you get 0. So when you differentiate this using implicit differentiation, you get 4y dy dx plus these two functions here. It's a product of two functions there. So then we isolate the first one, 4x there, and differentiate the second function. We keep the second function and differentiate the second function there. So after we do that, we come here, we keep this the way it is there. So when you differentiate this one here, we notice to say the x and the y are different there, so we introduce dy dx after differentiating there, plus this side, if you just differentiate 4x with respect to x there, you just get 4y like this. Okay, so after that there, we took this positive 4 here, it crosses the equal sign, it becomes negative there, so then we just factor out dy dx this side equal to this, then we divide both sides, and hence we have our final answer here. Okay, so let's now look at the next question here. So our next question here reads, the total surface area of a right circular cylinder of radius r and height h is given by s is equal to 2 pi r squared plus 2 pi r h. So if s is a constant, find the r dh here. So this means that we need to differentiate this expression here with respect to h. So we need to differentiate this whole expression that we have there with respect to h. So what we do here, the first thing is we're going to write this expression that we have there of s is equals to 2 pi r squared plus 2 pi r h like this. So now we just put a statement under there to show that we're differentiating with respect to h. So it's a differentiating throughout with respect to h. So differentiating throughout with respect to h, we're going to differentiate the left hand side with respect to h. We differentiate the first term with respect to h, 2 pi r squared, plus differentiating this function as well, or rather this term, with respect to h, we have 2 pi r h like this. So now we can start our differentiation. So remember, we were taught to say this h that we have here is a constant. So every time you differentiate a constant, you get a 0 there, equal to, so now here again we're differentiating r squared with respect to h. So these are two different variables there. So the method of differentiation that we use is just the implicit differentiation. So now when we differentiate this here, we're going to differentiate this the normal way, and since r is a different variable from h here, we're going to introduce a dh there. So if you differentiate this, you're going to get 4 pi r, then we introduce dr dh like this, plus, so now if you notice here, we've got 2 pi r h, meaning that this h and this r here, they become, or rather there are two different functions that we have there. So now if there are two different functions that we have there, we need to use the product rule. So for the product rule, we keep the first function, differentiate the second function, and we keep the second function, the second function, and differentiate the first function there. So we're saying for this part here, we're going to keep the 2 pi r and differentiate with respect to h, our h there, plus we keep the second function h and differentiate with respect to h, the 2 pi r like this. So now here we're going to keep this side the way it is here. 0 is equal to 4 pi r dr dh, plus when you differentiate this here, this is h, we're differentiating h with respect to h, we're just going to get 1 there. So we just have 2 pi r like this for this term. So now when you differentiate this function here that we have there, we're going to differentiate r with respect to h. So r is a different variable from h there. So now if these two are two different variables there, we're going to differentiate r the normal way there, and we introduce dr dh because we're differentiating it with respect to a different variable, which is h there. So meaning that here we're going to have 2 pi h dr dh like this. So now, since we've done all the differentiation that's there, the question requires us to find dr dh there. So how do we do that? We're just going to group the like terms. So of course the first term here has dr dh, and the third term has what? Dr dh there. So meaning that we can take this, it crosses the equal sign, so we're just going to flip it this way. So we have 4 pi r dr dh, plus this, we have 2 pi r dr dh, equal to, when this crosses the equal sign, it becomes a negative, so we have negative 2 pi r there. So then here we can just factor out the dr dh there. So when we factor out the dr dh, we're going to have 4 pi r like this, plus 2 pi r, close, we put them we close the brackets like that. Then we have dr dh there. So then equal to negative 2 pi r. Okay, so now if this is the case that we have here, we need to isolate the dr dh this side. So to do that, we're going to divide by this on both sides there. So let's just do this on the next piece of paper. So now we have 4 pi r this side plus 2 pi r there, dr dh equal to negative 2 pi r there. So now what we do there is we're going to divide both sides by this. So if you divide both sides by 4 by r plus 2 by r, we also divide this side by 4 by r plus, oh sorry,